Hello, once again, and welcome to this session. As usual, we'll recap what it is we learned in the previous session. In session 10, we looked at system flowcharts. We explained what are data flow diagrams. We looked at decision tables, and we wound up the session by looking at the hierarchy input process output charts, that is the HIPPO charts. Today we'll be looking at session 11, elements of programming language. Let's start by looking at the session objectives. By the end of today's session, you'll be in a position to define what is a software program, describe the program development process, explain the programming languages. You'll also be in a position to explain what is program execution and also explain what is program testing. Let's get started. Introduction. Now, programming languages are used to create either system software or application software, and system software is used to control the operations of the computer hardware. Application software helps the user to perform tasks with the help of both system software and computer hardware. Let's look at software programs. A software program is a set of written procedures or instructions in a sequential format that are used to perform a specific task by a computer. These are usually created for business requirements as well as personal needs. Let's look at some of the characteristics that must be present in a software program. Now, this can also be looked at as the characteristics or qualities of a good program. We start by looking at scalability. Scalability is the ability of your program to grow as the organization grows. Most organizations start small and with time they expand. Your software or program should grow with the organization. Security, we can't overlook the importance of security nowadays, especially with people trying to hack into systems. Think of a banking system or something like that. Security is very important in any program. Usability, this is pretty obvious. I'm quite sure in your laptop, mobile phone, or any other device that you're using, you have a browser, you have a music player or video player. The reason why you chose that particular program is because it's easy to use. Usability can also be termed as user friendliness. How easy is it to use your program or software? We have reusability. Reusability means that one program can be used in multiple places. Take a good example like a point of sale system. The point of sale system used in one supermarket can be easily reused in another supermarket with little or no modification. So that is what you're calling the reusability of your software. Modularity. Modularity, we've talked about modules. Modularity means that your program can be broken down or the software is able to do specific tasks broken down into small specific modules. There could be a login module, there could be a payment module, there could be a shopping module, and all that. That is what we're calling modularity of the program. Testability. This is something very important. Every program must be tested and tested thoroughly before it is put into use. This ensures that the program or software does what it is made to do in the first place. The next is interoperability. This means that your system should work with other existing systems. Example is point of sale software in a restaurant, in a supermarket. It should allow various methods of payment. There are those people who want to pay cash. There are those who want to pay using mobile money payments. There are those who want to pay using debit cards or credit cards. It should allow integration with all these other systems. Accuracy means that your program should give the correct results based on a given set of inputs. And accuracy goes together with the last one, although we look at it just in a while. Efficiency, your program should use the computer resources efficiently. We don't want your program hogging either memory or hogging CPU cycles. It should take the minimum amount of RAM and the minimum amount of processor cycles to do what it's supposed to do. Flexibility, Flexibility means that your program can handle erroneous data. At times, this is also called robustness. The user can enter some erroneous data, and your program should be in a position to tell the user what went wrong and how to make corrections. Portability means that your program can be ran in different or executed in different environments. It can run on Windows, can run on the Linux and the various distributions of Linux, Unix, or something like the Mac operating system with little or no changes in the code. That is what we're calling portability. And of course, reliability, I was saying it goes together with accuracy. If your program is always accurate, it gives accurate results, then people tend to rely on your program. If your program gives inaccurate results, then your program becomes unreliable. Therefore, make sure your program is accurate. It should also give the expected feedback to ensure that your program or software is reliable. Let's move on. The program development process. The figure shows the program development process. We have planning. Planning means you want to write down all the activities or to lay down a path that you're going to follow to come up with a software. The next thing is to implement the plan, and you implement the plan by developing the software or program which you want to develop. After the program is developed, the next thing we do is to test that program or software thoroughly. After you test it, you can then go ahead and install it. This is what you're calling deployment. Could be a program, could be a software, could be a website. You deploy it in the relevant either computer, mobile phone, or if it's a website, you upload it in the server. After that, your software or program needs to be maintained. Maintenance involves adding features, removing features, adding support for newer gadgets, and so on. That is what we call maintenance. And of course, at the end of that, your program dies a natural death and you can move on to a newer version. Programming languages. A programming language is a language designed or a tool designed using a formal code of reserved words and symbols. Reserved words are called keywords, and symbols which express the process to be followed by the computer. It contains the instructions which need to be provided to the computer to perform tasks in a precise manner. We have different types of programming languages, and these are given here. Now, for easier understanding, the programming languages are classified into the following types. We have structured programming. I would like you to look at session 7. We covered structured programming in that particular session. You can go back and watch the video. We have object-oriented. We have object-oriented programming. This is where we program based on the various objects which will be interacting in a system. Like if we have a school management system, the objects could be students, we could have the subjects, we could have the courses, trainers, and so on. If it's a point of sale system, we could have the customer, we could have an order, we could have a staff member, and so on. That is object-oriented programming. The focus is on the objects which are going to be interacting with each other. Next, we have aspect-oriented programming. Aspect-oriented programming focuses on an area or an aspect of interest, like could be something like security. And by the way, aspect-oriented programming cuts across the board. For every program, aspects like security are very, very important. Aspects like reliability are very, very important. Now that is what you're calling aspect-oriented programming. It focuses on the bigger picture of your software once it is complete. We move on. Features of programming languages. Some of the common features of programming languages are given below. Number one, all languages must be compiled, preferably using a compiler. A compiler is a tool that we use to convert the source code into something that the machine can actually execute. Okay? There can be different ways to implement the compiling process, but the process must be followed for all the programming languages. Number two, a program should have memory handling and data storage facilities. Usually arrays are used for data storage, and they're also known as data structures. So the data structures basically are what we use to hold the data that our program will be processing, or the data that will have been processed after after your program processes that particular data. We have the control statements, which must be included in a programming language for logical implementation in the program. The control statements include things like we have the loops, which we discussed earlier, or something like the decision-making constructs. Next, we have programs, functions, and procedures should be written as well as provisions made for editing your program as required. The built-in functionalities of a program, such as classes and functions, must be used to write better programs, meaning that commonly repeated tasks or commonly used values should be created in a programming language. We either call them libraries or APIs. Now, libraries must be created in a software program so that these libraries can be used in other software programs also, just to what I was alluding to earlier. Most programming languages support exception handling, and this feature of a programming language must be used to find any errors that may be present in the computer program which is being developed. An exception is an occurrence that happens during your program execution, and it can either be caused by some erroneous data or some unpredicted or unforeseen event happening. Like, let's say the user could enter some erroneous data. Your program should handle that, and that is where we are saying we have the exception handling mechanism. This is what makes your program flexible, or it provides robustness in your program. Operators must be used to execute operations, especially those that are mathematical in nature. You remember we talked about operators. Ground rules for writing programs must be specified and followed by all programmers before starting to write a code for the program. That is what we talked about, planning and following the rules which are given for that particular programming language. Finally, the procedures are used to execute the program, and functions must be used to return values after the execution of the program. If like you're finding out the discount to be given to a particular customer, it must give you the correct amount of the discount. We don't want to overcharge the customer. We also don't want to incur a loss for the business. We must balance everything. We move on. Program execution. Program execution refers to the process where the computer performs the instructions which are given to it by the computer program. After the tasks are performed, the user receives some certain results as specified in the program. The two methods that are used to execute a program written in a high-level language are given below. We have an interpreter and we have the compiler. Now here, this is where we'll always be starting. We'll write some source code in some programming language, either C, C++, C# or Java. We could also use scripting languages like PHP or CGI or anything else. Now, once we have this source code, for most programming languages like C, the code will be compiled. After it is compiled, it will then give you an object file and an executable, and then after that you can execute that and your program can perform the specified tasks. We could also have the process of compilation and interpretation, like Java does this. It does both compilation and interpretation. We could also have the external libraries. External libraries could be something that is written by third-party developers, and you can include this in your program as well. We could see this in semester 4, like when learning Java EE. We could use something like the Struts framework. Struts framework is not inbuilt in Java. It's something that you add. That is what you're calling an example of an external library. Okay. Now, compilation, interpretation, then finally we get the result given down here. Program testing. Program testing refers to the process of validating, evaluating, and verifying the capability of a software program and determining if the software program has met the required or expected results. Some of the aspects that form part of the testing are given below. Number one, the software must meet the requirements specified. Remember, we said that as a programmer, you want to develop an application to meet your clients' or customers' specifications. All the operations of the software must be in working condition. You must ensure that all modules are working. The implementation of the software at the client end must not create any issues, meaning that once you install that particular software on the client's computers or maybe in a phone or could be a website, then it should work flawlessly or with minimal interruption. And the software must satisfy or meet the needs of the users who are using that particular software. I'm quite sure you have installed some software on your phone and it has frustrated you, and obviously you have had to uninstall it. We don't want people doing that to our software. Let's move on. The popular software testing tools are given below. We have the HP Quick Test Pro, Rational Robot, we have Eggplant, Silk Test, Test Complete, Test Partner, Test Manager, and Visual Studio Test Professional. The process of testing is given in this figure below. We start by planning the tests, and we also analyze the tests to see if they meet or they cover as many areas as possible or a broad spectrum. The next thing is to design the actual tests, and you do this by creating and verifying those particular tests. Then we start now the testing phase. After that, we also do performance testing. Performance testing basically evaluates how well your software performs under stress. Then, of course, you need to document the results of your tests. And after that, there are those actions which will be taken after the implementation of the tests. Could be something like corrective actions most of the time. So with that, we've come to the end of this particular session and this module as well. Let's look at what we've learned in this particular session. Software programs are a set of written procedures or instructions in a sequential format which are used to perform specific tasks by a computer. The program development process includes planning, implementation, testing, deployment, and maintenance. A programming language is a language designed using formal codes of reserved words and symbols that express the process to be followed by a computer. The programming languages are classified as structured programming, object-oriented programming, and aspect-oriented programming. An interpreter is used to execute instructions that are written in a high-level language. The compiler is used to translate the source code into object code. And program testing is the process of validating, evaluating, and verifying the capability of a software program and determining if the software program has met the required or expected results. With that, we've come to the end of the session and also the module. And our next module will be the C programming module. See you then. Nice time and God bless.